Well, hi there. This is an insect. And insects are, at least in terms of identified species, the single most successful group of animals on the planet. There are more described species of beetles, just beetles, than there are plants. You've probably heard that we're living in the age of mammals. Well, not only are there more species of extant dinosaurs than there are mammals, but there are more species of cockroaches, just cockroaches, than mammals. And cockroaches are barely in the top 10 for the most speciose groups of insects. It is estimated that for every human walking around on this planet right now, there are well over 2 million ants. There are twice as many species of flies as there are vertebrates. All vertebrates. And they're only the third most speciose group of insects. Insects are what you might call insanely successful. And all of this despite the fact that they are almost completely absent from the Earth's oceans. And the fact that their blood doesn't transport oxygen. And they're tiny and physiologically cannot get very large. I mean, even the largest insect of all time, the giant griffin fly Meganeuropsis, had a wingspan well under a meter at just 28 inches and was only about 17 inches long. That's big for an insect, but it's pretty small compared to truly giant animals like, well, mallard ducks, for example. I guess what I'm saying is that this is never going to happen.
Get the antennae! Get the antennae! Get the other antenna! Get the other antenna! He's helpless without them!
Now, I recognize that these ants were irradiated by numerous nuclear tests, but the fact is that genetic variation is not the reason that insects stay small. This might be the most diverse group of animals on the planet. And I'm not saying this to make fun of this scene. It's one of my favorite scenes in all of cinematic history, for reasons I'll discuss later. But because insects have some serious constraints on size that you might not know about. I'd say that if you know one constraint, it's probably their skeleton. Not that they have one. The largest animals ever to walk on land had skeletons. It is where the skeleton is located.
On the outside.
Let's look at a box. A box that is 1 by 1 by 1 box units has a volume of 1 cubic box unit. To calculate its surface area, we need to take the area of each side, which in this case is 1 times 1, or 1 square box unit, and then multiply that by the number of sides, 6. Thus, this box has a surface area to volume ratio of 6 to 1. But if I scale the box up to 2 by 2 by 2, I now get a volume of 8 cubic box units, and a surface area of 4 times 6, or 24. Thus, the surface area to volume ratio is 24 to 8, or 3 to 1. If I scale it up to 3 by 3 by 3, the surface area to volume ratio is 54 to 27, or just 2 to 1. And if it's 10 by 10 by 10, then it's 600 to 1,000, or just 0.6 to 1. The larger the box, the smaller the surface area to volume ratio becomes, because surface area grows at a square rate and volume at a cubic rate. This isn't a big deal for a box that lives in the ocean, but on land, volume really matters because buoyancy doesn't help to counteract gravity, and weight is largely tied to volume. Meanwhile, the size of your exoskeleton is largely tied to surface area. What I'm saying is that an exoskeleton doesn't grow larger at a rate that counteracts the rate at which an irradiated ant would get heavier. So this explains why insects don't get as big as cars. But there are plenty of other terrestrial crustaceans, and yes, I'm saying that insects are crustaceans, that get much larger than the largest insect ever known to have existed. Like these coconut crabs that we found in Niue. And why were they able to get bigger in the past than they are now? The answers to those questions probably come down to the way that they breathe. They breathe funny. Of course, they're doing much better than our vertebrates, so maybe we're the ones that breathe funny. But as I said earlier, they don't transport oxygen with their blood. In fact, it can be argued that the fluid that insects pump around their bodies shouldn't even be considered blood. It's generally called hemolymph instead of blood. But their cells still need oxygen. So how do they get it? Direct delivery via pipes called a tracheal system. And this works just great if you're small. But the larger they get, the longer these thin pipes need to be. And you can try this experiment sometime, but it is possible to breathe through a thin straw. But the longer the straw, the harder it gets to be. And given that the intakes are on the surface of the insect, you are again running into that surface area to volume ratio problem. So this probably explains why insects are the size that they are. But why did some get much larger in the past? Well, it may interest you to know that the largest insects in history also existed at the time when atmospheric oxygen levels were the highest that they've ever been. And to answer your question, no, insects would not get noticeably larger if you raise them in a high oxygen environment. But if you keep oxygen levels high for thousands of generations and select for large body size, I would wager good money that you could produce some insects that are larger than any currently living on Earth. But there are still some big and absolutely crazy insects. I mean, almost half of all eukaryotic species are insects. And today I want to blast through the nearly 30 orders of insects so that you have a big picture idea of how much crazy diversity there really is and how it's all related. Ridge is one of our longtime partners, and for good reason. Their products are made for life and built to last. I've been carrying Ridge Wallet exclusively for the last many years, and I've got to tell you, this one, the Biflex, is by far my favorite ever. I love it. I don't know if I'll be moving on from this. And these pens, the Ridge pens, are my favorite pens in the world. They're bolt action, they're heavy duty, they're just super cool. And this Father's Day, you can save up to 40% on gear that dads will love and use every single day. Over the years, Ridge has gone way beyond wallets. They now offer rings, pens, travel gear, which I just used extensively on my trip to South Africa, key and phone cases, and their newest addition, Ridge power banks. We're really excited about these. They're compact but powerful with built-in Lightning and USB-C cables, MagSafe compatibility, and a built-in kickstand for hands-free viewing. You get up to 3 full phone charges without the extra cords or clutter. Power banks like these have been absolutely essential to all of our overseas adventures that we've had. And this is probably the coolest one I've ever seen. So whether you're upgrading your own gear or picking out something great for dad, head over to ridge.com/Clint to check out their Father's Day sale. That's ridge.com/Clint for up to 40% off. As always, a big thanks to our friends at Ridge for sponsoring this video and for sticking with us all these years. Let's get back to it. Insects are, as previously mentioned, crustaceans. They are arthropods in the clade Pancrustacea, nested within the pancrustacean clade Hexapoda, the 6-legged crustaceans. And insects do have 6 legs, all 6 originating from the middle of 3 body segments called the thorax. Even in beetles, where sometimes it really doesn't look like this is the case. But legs are far from their only appendages. They have 2, but not more than 2, antennae on their heads. And some would say that they're helpless without them. And fair enough, the bristles on those antennae allow them to feel things tactily, but they also use them to smell, detect temperature, humidity, atmospheric pressure, and in some cases, even sound. In other words, insects use their antennae for every sense that they have except sight and sometimes hearing. Sight is accomplished thanks to a pair of compound eyes, each composed of as many as 30,000 individual ommatidia, as well as 2 or 3 ocelli. In addition to legs, most insects also have 2 pairs of wings that originate from the last 2 segments of the thorax. Moving back to the head, you find the mouth parts. What differentiates insects from other hexapods is that the mouth parts are located outside of the head capsule. It might seem like a small difference, but apparently it has made a big difference. Insects rule the world, you know. And they can have a pretty wild diversity of mouth parts, allowing them to feed on a broad diversity of foods and rule the world. The third body region, called the abdomen, often lacks appendages and is usually not as hard as the other two, as it's less sclerotized than the head and thorax. But it contains many important organs, such as the respiratory, digestive, and reproductive organs. So it's still kind of a big deal. The order most distantly related to all other extant insects, the hagfish of insects, if you will, is the order Archaeognatha, the slightly over 500 species of humpback and jumping bristletails. Bristletails due to the 3 appendages protruding from the back of their abdomens. 2 circi flanking the noticeably larger appendix dorsalis. In general, these are pretty unique looking insects. Really, the only thing you would confuse them with would be members of the order Zygentoma, the silverfish and firebrats, of which there are also just over 500 species. And while these are among the closest relatives of the bristletails, the members of the Zygentoma are more closely related to all other extant insects than they are to the bristletails. But they do look very similar to one another. And given that these are the 2 most basal members of the insecta, this probably gives us some window into what the common ancestors of all insects look like. That said, it is easy to distinguish between the 2 if you get a good look at them. Or if it suddenly launches itself into the air. Both lack wings, but bristletails can use their tails to throw themselves great distances. They also tend to be laterally flattened, like a sunfish, and not dorsoventrally flattened, like a stingray or a silverfish, with a somewhat humped appearance. And members of the Zygentoma are not only flat, but also tend to have circi that are roughly the same length as the appendix dorsalis. All of the remaining insects fall into a clade called Pterygoda, in reference to their defining feature, wings. Obviously, not all insects have wings. Like all arthropods, insects grow by molting the cuticle, a process called ecdysis, something that they share with their close relatives, like velvet worms, tardigrades, and nematodes in the clade Ecdysozoa. Unlike the insects that we have discussed so far, winged insects tend to cease molting once they reach adulthood, and thus pass through a specific number of molts during their lifetimes, with the stages between molts called instars. And generally, they only possess functional wings following their final terminal molt, an adult stage called an imago. The winged insects are themselves divided into 2 clades, the Paleoptera and the Neoptera, the ancient wings and the new wings. Truth is that both groups have highly evolved wings, and some of the best flying insects in the world do so with ancient wings, like the nearly 6,000 species of dragonflies and damselflies in the order Odonata. We could make entire videos just about how they fly and how their wings have changed over the last few 100 million years. And that's not even including how their eyes function, which is absolutely bonkers. As juveniles, odonates are fully aquatic, but they are terrifying underwater predators. And speaking of butts, dragonfly larvae use their anuses to fire water and provide them with jet propulsion. No big deal. It's a really convenient side effect of the fact that they draw water in and out of their anus to ventilate their internal gills. Damselflies, on the other hand, have external gills and can't do butt propulsion. But they can use the gills for propulsion, a bit like the caudal fin of, some sort of a waterfish. By the way, if anyone can explain to me how gills work in insects like these, given that most insects do not transport oxygen in their hemolymph, I would greatly appreciate the explanation. I'm starting to ask questions that are difficult to Google, so thank you for your help. But adult odonates can be identified by their 4 large flight wings and round heads with small antennae. Dragonflies tend to be heavier bodied with wings that do not fold over the body, whereas damselflies are the opposite of that. Their closest relatives are the more than 3,000 species of mayflies of the order Ephemeroptera, which is an absolutely savage name if you ask me. I mean, it means wings that last for a short time. And I get that. Their imago stage is often notoriously short. But they are an oddball in that the imago stage is not the only stage at which they have functional wings. They also commonly have wings in the instar before the imago, called the subimago. So they sort of have wings for a long time. You can generally identify a subimago by the fact that the wings are cloudy instead of clear. And imago and subimago mayflies can be identified by the way that they hold their wings, a bit like butterflies, up over the body, pointed to the sky. But other than the wings, they really look a lot like silverfish or bristletails, especially as juveniles. Though they are aquatic as juveniles, with up to 7 pairs of gills on the sides of the abdomen, and wing buds on later instars. All of the remaining insects fall into the new-winged group, which contains 2 big clades. And I really mean big. Huge clades. The Polyneoptera and the Eumetabula. And I cannot tell you which of these clades contains the cooler insects. So I'll just start with the smaller of the 2 enormous clades and make my way to the most successful clade of animals on the planet. So, the Polyneoptera. The many new wings. I don't get the name. They don't have any more wings than most of the other winged insects, but whatever. Of the many new winged insects, the 2 orders most distantly related to the rest are the orders Zoroptera and Dermaptera. And of the 2, the one you are least likely to have ever seen in your life are the 37 species of Zoropterans, often called angel insects, a name which somewhat escapes me. Other than the fact that they tend to be white and many can shed their wings like the angels in the movie Dogma. Of course, Zoroptera isn't much better. It means pure wingless. And obviously some of them have wings, though not all species. And again, many can shed them. What they really look like are not angels, well, unless you think termites look like angels, in which case they totally look like angels. They even tend to live in colonies. The easiest way to identify them is by their antennae, which are long and have 9 very conspicuous segments. And while they tend to live on wood and under bark, they cannot chew through wood like their, well, distantly related and angelic cousins. So their closest relatives are not termites. Their closest relatives are the roughly 2,000 species of earwigs, or as I called them growing up, pincher bugs, though they're not true bugs. Of course, they don't tend to crawl into your ears or wear wigs, so what's in a name? A Dermapteran by any other name would smell as sweet. Now, interestingly, the aptera in Dermaptera does not mean no wings. They are dermatera, skin wings. And rather shockingly, they do have wings. Big wings that are shaped rather like a human ear. And that is the actual source of the common name. Wig relating to beetle, which they're not. But like beetles, they hide their long hind wings under shorter, in this case, crazy short, protective forewings, which in the case of earwigs are leathery, skin-like if you will, and are called tegmina, which is the typical term for leathery forewings that cover the hind wings. In beetles, they're more sclerotized and hard and are called elytra. And I would argue that the hind wings of earwigs are among the most angelic in appearance of all insect wings. Of course, their circi are some of the more satanic looking of all abdominal appendages, so that probably cost them the name angel insects. In general, you can probably recognize an earwig. But some are wingless and eyeless, and their circi are much less pinchy, like the 2 families of ectoparasites of small mammals in Africa and Asia. When you have 2,000 species of something, it's bound to be a few oddballs. The next most distantly related order within the Polyneoptera are the nearly 4,000 species of stoneflies in the order Plecoptera. That's right, there is almost a stonefly for every species of mammal, and yet most people have never even heard of them. Like mayflies, dragonflies, and damselflies, but unlike their closer relatives that we've just discussed, stoneflies begin their lives in the aquatic environment. That said, they look almost identical to adults, just without wings, which are also absent on the fully aquatic species of stoneflies, even as adults. So some never leave the water, and really none of them are great flyers. So putting fly in their name was a bit unwarranted. It's a bit like calling the galliform birds dino flies. I mean, yeah, most of them can fly, but they're not great at it. In general, stoneflies are fairly unremarkable as insects. They have 2 circi and their wings fold over their bodies, if they have wings at all. And that pretty much sets them apart from everything else we've discussed. After the stoneflies, angel insects, and earwigs, the next most distantly related order of polyneopteran insects are the order Orthoptera. An order that you may not know by name, but that you almost certainly know, as it contains almost 24,000 species of crickets, grasshoppers, and katydids. And if there's one thing that sets them apart from all other insects, it's those big jumping legs, including this little gem that we found in the Amazon rainforest. Not to mention these. And I want to mention that our entire trip to the Amazon and all of the videos that came from it were all made possible by our supporters at Patreon. And I can tell you that on all future trips, I am going to focus much more heavily on arthropod content. So if you would like to see that happen sooner than later, please consider supporting us on Patreon. And that gets us to the large clade within the Polyneoptera, which contains the remaining 6 orders. This clade itself is divided into 2 main clades, one with 2 orders and the other with 4. And since I love mantises, I'll start with the smaller clade. It contains mantises! Though I will say that the larger clade also contains some rad insects, and a few groups that you've probably never seen in your life. Now, I would say that you can easily distinguish the roughly 2,400 species of mantises in the order Mantodia from anything else by their pivoting triangular heads and raptorial arms. But that actually wouldn't be enough. So I'll add that their forewings, when they have them, are generally leathery tegmina. And their antennae tend to be long and thin. If you look at this thing, whatever it is, it has forewings that are clear, like the hind wings, and the antennae are thicker, more like those of a yellow jacket. But this thing, whatever it is not a close relative of mantises. In fact, the closest living relatives of mantises are these, the more than 7,000 species of cockroaches, including termites, in the order Blatodia. And yes, I did just say that termites are cockroaches. Because they are. By the way, don't hesitate to request videos diving deeper into any of these orders. I could talk about nothing but insects for the next 6 years and enjoy the heck out of it. 1 year of videos for each walking leg. Seems appropriate. But termites, as it turns out, are just a clade of eusocial wood-eating cockroaches. Which I don't think really helps or hinders the brands of cockroaches or termites. People tend to not like either of them for different reasons. But I love both of them. Though it helps that I live in the desert where they neither live uninvited in my house nor do they attempt to eat it. And though termites are cockroaches, when it comes to morphological identification, I'll talk about them separately. Non-termite cockroaches are generally dark brownish in color. They tend to be dorsoventrally flattened with an overall oval shape with a pair of cerci coming from near the end of the abdomen. The first segment of the thorax is covered with a shield-like pronotum that covers part of the head as well, obscuring the head to some degree when viewing them from above. From below, you can see a head that looks considerably like that of their closest living relatives, mantises. Their first pair of wings tend to be leathery, like with mantises, and cover the second pair when they're folded over the body. Though, like mantises, not all species possess wings. Termites, on the other hand, tend to be white and super colonial, with different castes like workers, soldiers, and because they're eusocial, kings and queens. Most are wingless, though reproductive castes often have wings for a period of their lives. They look a lot like angel insects, but with far more segments to their antennae than 9, and the ability to chew through wood, and...
They're 5 times our size, and they shoot acid from their foreheads.
Well, if they're termites of the subfamily Nasuti termitinae, and you're 1/5 the size of one of their soldiers. They shoot that acid out of something called a fontanellar gun. So I understand if you want us to dig in deeper to the termites in the future. But there is still one more clade in the Polyneoptera that we have to discuss right now because it contains some awesome insects and some that will almost certainly be new to you. In fact, of the 4 remaining orders, I will be impressed if you know more than one. This one. The over 3,000 species of walking sticks and leaf insects in the order Phasmatodia. Now, I love pretty much all insects, but these have to be some of the most broadly appreciated of all insects. Right up there with butterflies and ladybugs, which also aren't bugs, but they are broadly loved. How could anyone not love a stick insect? The only reason that I can see is that you don't know about stick insects. They're wonderful. And while many are tiny, some are enormous, reaching lengths over 60 centimeters. That's over 2 feet long. We certainly found some giants in the Amazon. They may or may not have wings, but when they do, the first pair tends to be kind of hardened or leathery and protect the second pair. In general, they look like sticks or leaves, but with legs. Not big hopping hind legs or raptorial grabbing forelegs, as some grasshoppers and mantises are also excellent stick mimics. Those that look like leaves are dorsoventrally flattened, where most other leaf mimic insects are laterally flattened. Their closest relatives are a group that I'll be very impressed if you have ever seen before, though there are almost 500 species. And those would be the web spinners of the order Embioptera. At a glance, they look a bit like rove beetles. But they're not. They're not even close. Though they do have long, flexible bodies and wings that are inconspicuous in most cases. Though some web spinners have long wings. Your big giveaways will be the big, thick Spider-Man web spinners that they have on their forelegs, and the fact that you found them living in a little group in a giant web that they made. The closest relatives of the web spinners and the stick insects are the remaining two orders in this clade. The orders Mantophasmatodia and Grylloblattodia, which together only account for about 50 species. And you've probably never seen any of them. But they are the gladiators and ice crawlers. So you know they're cool. There are about 34 species of ice crawlers in the order Grylloblattodia, which should mean something like cricket cockroach. They're neither of these things, but they do look a bit like wingless, pronotumless cockroaches with long circi. Though I think they look more like earwigs of some sort. But the best way to tell if it's an ice crawler is to ask yourself, am I on top of a mountain or at the edge of a glacier? If the answer is no, it's probably not an ice crawler. If the temperature is above 10 degrees Celsius, it's probably not an ice crawler. But if the answer is yes, you've found a very cool insect indeed. No wings, long circi, very cold, ice crawler. But if you like obscure insect orders with names that are a combination of other insect groups that they are not, then you're also going to love the closest relatives of the cricket cockroaches, the 15 species of mantis walking sticks of the order Mantophasmatodia, better known as gladiators. And they're from Africa, so they're African gladiators, to avoid confusion with the American variety, or the Roman ones.
Are you not entertained? Are you not entertained?
Really, they look like wingless stick insects. I really don't get the comparison to mantises other than the fact that they're carnivorous. To me, they look more like grasshoppers than mantises. But if you're in Africa, watching something that looks like a wingless little walking stick eat another insect, well, you might be very lucky. To this point, we've been looking entirely at insects with mandible-style biting jaws and incomplete metamorphosis, in that their juveniles, called nymphs, look essentially like wingless adults and do not pass through any sort of a pupal stage. However, the remaining clade of insects, the most successful clade of animals on the planet, the Eumetabula, is where we're going to break free of that mold. Let's put it this way. There are 5 orders in the Eumetabula with at least 4 times as many species as the most speciose order that we've discussed so far. One has more than 15 times as many species. And there are just as many orders in this single clade as in all of the clades that we've discussed so far. Now, I already said that the Eumetabula were going to break free of the mandibles and incomplete metamorphosis mold. But maybe not right away. Because the Eumetabula contains 2 clades, and one of them, well, it might have some members that still walk the way of the ancients. And that clade is the Paraneoptera. And this group is wonderful, as it includes the bugs, the true bugs. Obviously, you can call anything from a beetle to a bunny bugs, but if you don't want to get laughed out of an entomology conference, then you'd better save the term for members of the Hemiptera. And we'll get to them in a second. But first, we have to take a somewhat unpleasant detour into the order Socodia, the hagfish of the Paraneoptera. In fact, they're such an oddball group that the Paraneoptera is unsure that it even wants to claim them. Some phylogenies place them as sister to the Holometabula, the other clade in the Eumetabula. But wherever you put them, well, they are what they are. Lice. specifically bark lice, book lice, and parasitic lice. But not all parasitic lice. For example, tongue-eating lice are not part of this order, though we do have a video that talks all about those as well. But they aren't true lice, though, like true lice, they are crustaceans. Same thing goes for fish lice. But the members of the Socodia, well, they are lice. And they're insects. So we better talk about them. Especially since most people probably have no idea what they look like or what they do. Despite the fact that there are more than 11,000 described species of them. That's more species than birds and more than twice the number of described mammals. Despite the fact that lice have a nasty reputation, many are harmless to humans. Bark lice, for example, feed mostly on algae and lichens on trees. Book lice eat the glue used to bind books. And in addition to old books and micro-photosynthetic organisms, lice generally feed on things like fungi and detritus. Many fly, though some are wingless, even as adults. Some spin silk with their mouths. And many have mandibles, though good luck seeing them without some sort of a magnifying device. They tend to be tiny. Not just the mandibles, but the whole louse. No wonder 11,000 species were basically able to fly, or walk in many cases, under your radar for so long. Though there are 3 species that you probably do know about. The head louse, the human body louse, also known as the cootie, and the ever-popular crab louse, or pubic louse. For what it's worth, our understanding of molecular biology has allowed us to use the divergence time of the human body louse from the head louse as a pretty good piece of evidence to reveal about when humans started wearing clothing. So there's a feather in your cap. Well, more accurately, there's a hitchhiker in your pants. And unlike their noggin-loving close cousins, body lice do transmit diseases, so that stinks. But that covers lice that suck blood from your head, shoulders, knees, and perhaps toes. But there is one place left. And since human blood-sucking lice do not jump or fly, they generally can only be spread by direct contact with an infected human. So, you probably get the idea how you get them there. And though we could probably be done talking about lice already, I'll mention that head lice tend to be more pigmented in places where people have darker hair. So that's neat. Okay, let's move on to the 2 more surefire members of the Paraneoptera. The Hemiptera, true bugs, and the Thysanoptera, thrips. I love bugs. And I'm not just talking about Herbie, though. Who couldn't love that guy? Bugs can generally be identified by the fact that they, like every group that we've discussed so far, have incomplete metamorphosis, where their nymphs look basically like wingless adults. And also by their piercing, sucking mouth parts that generally sit across the thorax when not in use. Like a little straw down their chests. Some hemipterans are easy to mistake for beetles, and understandably so. Both are often rather oval in shape with hardened wing covers made from their first pair of wings that can seal and protect the second pair of wings when not in use. Assuming that you're looking at adults, it can be difficult to tell them apart without looking at the mouth parts. Though you are unlikely to ever confuse a juvenile beetle for a juvenile bug. But if it has a straw down its chest, it's a bug. If it has bitey mandibles, it's a beetle. And that includes the inappropriately named ladybug, which is only a lady half of the time and is never a bug at all. So far, if you add up every order of insects that we have discussed in these 2 videos, we have talked about just over 60,000 species, which is insane. That's about the same as the total number of described vertebrate species. All of them. Well, there are over 100,000 species of just hemipterans. So wing covers and piercing sucking mouth parts, well, that recipe seems to be working out. While some look like beetles, such as shield bugs, water bugs, assassin bugs, and leaf-footed bugs, others look nothing like beetles, like cicadas, leafhoppers, aphids, and scale insects. Again, this order alone is almost twice as diverse as all of the insects that we've discussed so far put together. We definitely need a video about bugs someday soon. I mean, just check out this peanut bug that we found in the Amazon. Or these horrid king assassin bugs that we covered a couple of years ago. Or this bellistomatid that we'll be covering very soon. Bugs are amazing. And their closest living relatives are these. The nearly 8,000 species of thrips of the order Thysanoptera. And that's a lot of species for something that you've probably never heard of. There are more species of thrips than mammals, so what are they? Well, they're relatively small. I mean, really small, like less than 1 millimeter long, which means that you would need to line up at least 10 of them end to end to fill up a centimeter. A conga line of 25 of them wouldn't even be an inch long. They're small, though the longest in the world is over half an inch long. Quite the colossus. If you've ever heard of them before, you're either way into entomology or you keep plants because, well, they can be hard on plants, even carrying diseases that can impact many plant species. Though many are pollinators and others are carnivores that benefit plants, and most are fungivores. They're roughly the shape of a cigar and have crazy asymmetrical mouthparts that are diagnostic for the group. But if you can't get a good look at their jaws, the wings of flighted thrips are probably the best indicator of what you have. Each wing looks basically like a little feather. Very odd. Anyway, Paraneoptera, the clade that we've been discussing, means next to the new wings. Which is funny because it is within the new winged insects of the Neoptera. That's like being here inside of Clint's reptile room and being told that you're next to Clint's reptile room. You probably need to update your GPS. So the next two new winged insects are themselves new winged insects. And all that is meant by new wings is that the wings can fold over the abdomen. Mantises, cockroaches, and grasshoppers, among others, are also new winged. So the Paraneopterans are not even the hagfish of neopterans. So the next to new wings are embedded deeply within the new wings and are about as next to the new wings as your skeleton is next to you. Assuming that you're a human. I didn't mean to exclude you arthropods. That analogy wouldn't work the same way for you. But anyway, they may not be next to the new wings, but they are next to the most successful clade of all. A clade that makes Hemiptera look like it's putting up rookie numbers. The absurdly successful Holometabula. And there is one thing that truly sets the Holometabula apart from almost all of the insects that we've discussed so far. And that would be a complete metamorphosis. And I say almost all because it appears that this is something that they share with some male scale insects, which are hemipterans. So it appears to have evolved at least one other time in the insecta. But it is, for all intents and purposes, limited to the Holometabula. Up to this point, we have been discussing insects with incomplete metamorphosis that hatch out as nymphs that, in most cases, look essentially like wingless adults, and steadily get larger with each molt until they molt into a generally winged adult called Nemago. They never pass through any sort of a non-feeding stationary pupal stage. And when I ask my students whether they think that insects that pupate should be more or less successful than those that do not, they almost always guess that they should be less successful. How could it be beneficial to go through such a vulnerable period during development? And yet the numbers would suggest that it is beneficial. Despite only being one lineage among many, the Holometabula puts all of the others completely to shame. And I'll give you two big reasons why this is the case, though there are more. Holometabolous insects hatch out as larvae, which, in most cases, look and behave very differently from the adults that emerge from the pupal stage. One huge advantage of this is that each stage can specialize at performing very different tasks. Larvae can become very specialized at doing things that are most important for sexually immature organisms. Mostly finding food so that they can grow quickly and get big. The longer it takes to reach maturity, the more time you have to die before you can breed. And the larger you get, the more babies you can produce in many cases. So they can be great at growing, which is something that adult insects generally do not do at all. Once they reach the imago stage, their growing days are over. Some don't even feed. Some don't even have mouth parts because they only have one goal: find a mate, make some babies. And the adaptations needed for this goal are, in most cases, very different from the adaptations required for the former goal. When insects pupate and metamorphose, they can dramatically alter their form. And the larvae and imagos can each become highly specialized at their respective roles. But that's not all, because the second huge advantage, that's a big one. So generally speaking, of all of the species that you compete with on this entire planet, the species that you compete with the most directly is your own. As much as a deer or a dandelion might use some of the same resources that you need, assuming again that you're a human, other humans, well, they use pretty much every resource that you use. And in general, bigger, stronger individuals, well, they're going to win the competition. What this means is that when adults and juveniles of the same species compete for the same resources, it's harmful to both, and juveniles tend to lose the competition. Unless, of course, adults and juveniles are completely different and utilize totally different resources from one another. Because, I don't know, they went through a complete metamorphosis. And that is why, despite the clear drawbacks of passing through a pupal stage, and despite the fact that other clades of insects are, as a whole, extraordinarily successful, well, this clade puts all of the rest to shame. And the order least closely related to all of the other holometabolous insects is also one of my favorite orders of insects on the planet. An order that definitely needs its own video, if for no other reason than so I can explain why ants and bees are types of wasps, and why all of them are types of sawflies. But it is the more than 150,000 species of sawflies, wasps, ants, and bees in the order Hymenoptera. There is so much to talk about with this order. It will probably be a lot of videos. So if you want to see that sooner than later, don't hesitate to type, what's this about bees being wasps? Down in the comments. And if you've noticed that we have never made an ant the best pet insect video, it is because Mikey Bustos of Ants Canada and I have been planning to do it together for the last few years. But it's hard since he lives in the Philippines and I don't. So if you would like to send me to the Philippines to make that video, and who knows how many more, please consider supporting us on Patreon. But hymenopterans are small to medium-sized insects. Like most flying insects, they have two pairs of wings, which will differentiate them from some of their mimics that we'll discuss later. Many are parasites with long ovipositors that they use to place their eggs into, well, hard-to-reach places. And in many species, that ovipositor is also used as a stinger to inject acid and venom into prey and potential enemies. Sex in hymenopterans is generally determined by the number of chromosomes possessed, and that has resulted in eusociality developing multiple times across the order. We discuss that more in this video, as well as a lot of other amusing reproductive strategies. It was a doozy. The remainder of the holometabola, and indeed the insects, fall into two very large clades, the Panorpida and the Neuropteroidea, each containing 5 orders. Now you just heard about the absurd number of hymenopteran species alive today. It's way more than double the number of vertebrate species in the entire world, making it the 4th most speciose order in the holometabola, because the holometabolous insects rule the world. The Panorpida alone contains 2 orders with more species than the hymenopterans, and the Neuropteroidea contains the order for which the creator is rumored to have an inordinate fondness, the most speciose order of all, and it isn't particularly close. Arguably, the pinnacle of creation, assuming that it's not gorillas. And we'll save them for last. But don't worry, some of the most amazing insects in the world are in the Panorpida. So the wait will be a pleasant one. The 5 orders in the Panorpida are divided into 2 clades. The smaller of the 2, Amphis Menoptera, contains nearly 15,000 species of caddisflies of the order Trichoptera and the roughly 180,000 species of moths, including butterflies, of the order Lepidoptera. Which means that if you were upset that I told you that butterflies are crustaceans, I have even more bad news for you. But the good news is that moths, including butterflies, Well, they're doing great. They are hyperspeciose and are some of the most beloved insects on the planet, which helps explain why around 10% of all described organisms are lepidopterans. They're also pretty much the poster children for holometabula. Many people are shocked to find out how different juvenile beetles, flies, and bees are from adults, but pretty much everyone knows what baby butterflies are. In general, lepidopterans can be identified by their large, scale-covered, triangular wings and their nectar-sucking proboscises. Really, the only organism that you're likely to mix up with a lepidopteran, unless it's a bee mimic, would be their closest living relatives, the Trichoptera. But that would only be as adults. As juveniles, you can tell a caddisfly from a moth because, well, they're underwater in a little silken tube that may or may not be decorated with stones and all sorts of other objects that they thought they would use to build a crazy little house. But even as adults, you can distinguish them by the way that they fold their wings and their reduced mouth parts compared to their beloved fluttering cousins. The remaining 3 orders of the Panorpida fall into the clade Antleophora, which is probably the most disliked clade of insects, period. But whatever, they're still cool. The least closely related to the other 2 is the order Diptera, meaning 2 wings, which is odd for an insect, I know, but is only partially true. They have 4 wings, and all are used for flight, but only 2 are used for lift. The remaining 2 are reduced to little clubs called halteres, which wouldn't seem like they have much to do with flying, but they do. Because when a dipteran such as a fly, a mosquito, a crane fly, or a hoverfly starts to fly, the halteres begin to do what they do. Spin, creating a gyroscopic effect. Meaning that while they don't generate lift, they do stabilize the insect in flight. But the number of flight wings is still a great way to identify bee and wasp mimics that are, in reality, dipterans. If you see the halteres, that'll be a dead giveaway. But Diptera is greatly underappreciated. While there are more than 125,000 described species, that may represent only about 10% of the actual number of species. The world is full of flies, and people that want to formally describe their colorful, scale-winged, less bloodthirsty cousins that don't lay their eggs on poo. I guess what I'm saying is that you could probably name a fly after a person that you don't like every day for the rest of your life and hardly make a dent in dipteran diversity. But flies are voluptuous, and don't let anyone tell you otherwise. Their closest relatives are the less than 1,000 species of scorpion flies in the order Mecoptera, and the slightly over 2,000 species of fleas in the order Siphonaptera. Now, I just got done talking about horseflies, mosquitoes, and maggots, so I will give you just a tiny break before I talk about fleas. And we'll start with their closest relatives that look awesome, but aren't as cool as they look. This is a scorpion fly. Specifically, this is a male scorpion fly. You can tell that it's a scorpion fly by that really crazy face. But they get that name from that crazy tail. It looks like the metasoma and telson of a scorpion, but it isn't. Those would be his genitals. Their closest relatives are the blood-sucking, flightless, bounding insects that we call fleas. In fact, some phylogenies even place the fleas within the Mecoptera, so they may just be the world's worst scorpion flies. You know, since they don't fly, and they're the worst. I'm itchy just thinking about them. When I lived in Peru, at times I would have probably in the neighborhood of 100 bites at a time. It was high-level suffering. So let's talk about the Neuropteroidea. Its 5 orders are also divided into 2 clades. The larger of the 2, the Neuropterida, contains 3 orders that may all be new to you. At least, you may not have ever known what they were if you've ever seen them before. The smaller clade, the Coleopterida, contains 2 orders. And one of them will likely be new to you. But if you don't know the other, I have no idea what planet you live on. I can't even accuse you of living under a rock. I see them under rocks all the time. They may be the most successful order of animals on this planet, but I promised that I would save them for last. So we'll begin with the Neuropterida. which does contain this. We've been waiting a long time to find out what this is. And of the 3 orders in this clade, the one least related to the other 2 are these, the snakeflies of the order Raphidioptera. Now I have a little confession to make. I have a real hole in my mammal knowledge called antelopes. I can recognize and name a handful of them, but there are almost 100 different species. It's just too many. And yet, in the context of the Holometabula, finding out that there are only 160 species of snakeflies really makes you feel like they aren't doing well at all. And they aren't. They're pretty limited to more temperate parts of the northern hemisphere. They really reached their peak before the extinction of the non-avian dinosaurs. And given that these first appeared in the Jurassic, I feel bad for all the entomologists that didn't know what to call them until snakes first appeared in the early Cretaceous, when these were already in their heyday. But they are called snakeflies because of the conspicuously elongated first segment of their thorax. Combine that with the lack of hardened first wings called elytra and the lack of mantis-style raptorial forelimbs, and more than likely, you found a snakefly. And if you're going to confuse them with anything else, it would probably be with a member of the order Neuroptera, the lacewings. And don't beat yourself up. Lacewings look like all sorts of things, from moths to bees to dragonflies to praying mantises. This is an antlion. As a juvenile, it is pretty unmistakable. It lives in the middle of a sand cone and eats insects that fall into its sarlacc trap. But as an adult, many people who love dragonflies and don't pay much attention to antennae get them tattooed on themselves, only to find out at the first entomology conference that they attend that they have a rad antlion tattoo. This wonderful creature is a mantis fly. Not a mantis, not a dipteran, but a rad convergence on the praying mantis body form. Just without the leathery tegmina and with a very different looking juvenile form. And the roughly 6,000 species of lacewings are the closest relatives of the snakeflies, along with these, the closest relatives of the lacewings, the roughly 300 species of alderflies, dobson flies, and fish flies in the order Megaloptera, which generally look a lot like lacewings, but sometimes have some of the freakiest looking mandibles on the planet, though they're not nearly as horrifying as they look. They're mostly just for show. Like Jason. Scary looking, but actually pretty harmless. And I mean our producer Jason, not the one with the hockey mask. He's much less harmless. But these jaws are pretty much just for fencing. Some species don't even feed as adults. And interestingly, of all of the Holometabula, these undergo the least extensive metamorphosis, though the larval forms do eat. And that brings us to the Coleopterida, the final 2 insect orders. And I promised that one would likely be new to you. But if you've ever been looking at an insect and it suddenly burst open and a bunch of smaller insects came flying out of it, they were likely one of the roughly 600 species of twistwing flies in the order Strepsiptera. Yeah, they're endoparasites of larger insects after they get done eating their mother to death. These definitely belong in our next unusual mating strategies video, because I haven't even gotten to the way that they mate. It may be the most horrifying part of all. I tell you what, I'll start that video with these guys. But right now, we're finally gonna get to beetles. We could make this channel into Clint's Beetles, and we could make videos about nothing but beetles for the rest of my life and never run out of content. There are about 400,000 described species, and we're just getting warmed up. Let's put it this way. If you had me to take every described animal and put all of their names into a hat, then pull one out, you would have a 1 in 4 chance of pulling out the name of a beetle. Voluptuous dipterans are probably their only rivals for diversity among all animals on the planet. But if there's one thing that can put to shame the success of halteres and holometabolism, it's elytra and holometabolism. You might have noticed that the most successful group of insects without complete metamorphosis were the true bugs, which often have well-protected wings. Well, that recipe works for the holometabula as well. And perhaps even better. Beetles, unlike true bugs, have mandibular jaws. But their first set of wings is even more sclerotized into an even harder cover called an elytra. This allows beetles to both fly, which is hugely advantageous, and jam themselves into tight, but often safe, spaces where wings would generally make it impossible to go. Let's just take a minute to enjoy the incredible diversity of beetles. The well-known evolutionary biologist J.B.S. Haldane was once asked what his study of creation had taught him of the creator, to which he replied that he has an inordinate fondness for beetles, and so do I. I'll make a full video, possibly multiples, on beetles very soon. So let me know if you too have an inordinate fondness for beetles. And as always, like and subscribe, and we hope to see you real soon.
What is it? Species appears to be Camponotus trichitis. One of the family Formicidae. An ant. An ant.
My favorite thing is that it is the most accurate depiction of an academic that I've ever seen. Because they killed this thing, right? And they go, what is it? And he goes, the species appears to be Camponotus trichitis. Like that's going to mean anything to anybody. And then he goes, one of the family Formicidae. Also means nothing. And they're like, uh-huh. And now that he has fully established that he's the smartest one in the room, he goes, an ant. And they go, an ant? They're just there like, uh-huh. Okay. Oh, an ant? A normal human being leads off with, I think it's a giant ant. Because they know that's what they wanted to know. But the academic goes, no, no, no. I'm starting to ask questions that are difficult to Google. So thank you for your help.
I can't believe you don't know the answer.
I know, it's outrageous.
You were a biologist? Come on.
Yeah, what kind of zoologist doesn't know the answer to all animal questions?
Yeah, what the heck?
It is outrageous. Well, more accurately, there's a hitchhiker in your pants. Oh dear. Got a hair in my eye, but being the professional I am, I finished that sentence. Okay. It looks like the metasoma and telson of a scorpion. But it isn't. Those would be his genitals. You're welcome.
I was not expecting that one. Oh, jeez. Those are the genitals.
Yes, indeed.
That he proudly displays.
Absolutely.
As one.
If you had genitals like that, it's not the kind of thing you keep secret.
Oh my goodness. No stinging abilities.
No, well.
No tradition.
Yeah, not by the traditional definition of the word, no.
Jeez.
Though it does have some specific injecting capability.
Yeah, of course.
And I mean our producer Jason, not the one with the hockey mask. He's much less harmless.
Thanks.
Yeah. You're scary looking, but I've never known you to attack anybody.
So scary looking.
Yeah. Intimidating. Like, you probably just assume that people wet their pants on a regular basis when just out on a walk. People run screaming all the time. That's just normal human
really
behavior.
Uncomfortable because it starts to smell, especially in a closed room. Which,
Yep.
they all kind of congregate in the corners, which is weird.
Yeah.
Yeah.
Yeah. That's not normal behavior. Just so you know. Yeah, it's only.
I thought I was.
Only intimidating specimens like yourself elicit that sort of a reaction from people on a regular basis.
Yeah, no.
Yep.
I'm starting to pick up on that.
Yep. But really, you're harmless as a. What would it be? A Dobson fly? Yeah. Yeah. I just say we ban motorcycles from this road.
I'm with you.
Yeah.
I mean, it feels a little overreaching from like a government perspective, you know? But I'm with you.
What is government for if not to do my will?
No truer words.
What is that?
It's loud.
I think that was an airplane flying at the road level.
It's just trying to take off.
Doesn't sound like a car.